Hi, this is John Carney, product engineer at Cadence, and this is a walkthrough of Rigid Flex in OrCAD X. Rigid Flex requires a couple of things to be set up correctly. Primarily, you're going to want to set up your cross-section. You have to set up your design outline with your Rigid Flex zones and where it bends. And then you're going to want to make sure you have all your specific Rigid Flex constraints and DRCs set up. And then once you get those things in place, you'll have a decent Rigid Flex setup going on. So to start out with, we'll focus on the cross-section first. So for example, in a typical Rigid Flex design, you're going to have a rigid area of the design like this, another rigid area, and then these areas are going to be the flexible areas of the design that are going to have specific areas where they bend and fold. Typically, those things could be designed in a mechanical tool and imported into the OrCAD X database. And if that's the case, you can use IDX import to import all of that data. So a lot of mechanical tools support the definition of all of these zones and bends. And if that's the case, you'd use IDX import to import all that stuff in. If that's not the case, you can define and draw that stuff inside of OrCAD X layout. But first, let's take a look at the cross-section. So going under Tools, going under Cross-Section, and then we'll have the Cross-Section Editor open up here. I'm going to go ahead and make the cross-section full screen so we can take a look at it. So the Cross-Section Editor, when you first open it up, you're just going to have a tab here called All Stackups. This one is a little bit of a work in progress, but the mechanics of it are basically the same. So you're going to have All Stackups, and then once you start using this little plus sign to add additional stackups, you'll end up with a primary stackup and then multiple other stackups. So the work process is to basically first create the different stackups that are going to exist in the different areas of flex and rigid flex in your design, and then you're going to map those stackups to different areas of the PCB. So seen here, you have a primary stackup and a flex 1 and a flex stiffener and an LCD stiffener. Those are corresponding to, you can see here, this is called flex 1. That is one type of stackup that's going to be going on in that portion of the design, where this is the main PCB or primary stackup. And I'll show you how to map those in a little bit. So the first thing you're going to have is your primary stackup or all stackups, right? So all stackups is going to contain basically any layer of any type that's going to exist anywhere in your PCB. And you also have this kind of cross-sectional view here that you can view and see the different copper layers, dielectric layers, masks, and cover lays, and where they may or may not exist in the design. And that is also represented by these check boxes here. So you get a column for each one of the different types of stackups, and then you have each row corresponds to a layer or type of material with its purpose that you can then check and say that this particular layer exists on, you know, those particular stackups as well. It may exist, it may not exist. Here you have your primary stackup, and this is your primary rigid portion of the design, or your primary conductor layers. And then this inner 2 and inner 1 layer are the ones that also go through all the other flexible areas of the design. So the way you go about building this up is in the All Stackups tab. When you first open it up, you can right mouse button on any particular layer you want to work on. So let's say you want to add some more mask layers above the top layer. If you click your right mouse button on top, you'll have some options for adding layers, adding a layer pair below. A layer pair would automatically put in a conductor layer and a dielectric, so you don't have to put them both in at once. Or add layers, just going to be an individual layer. If you choose add layers, it will then bring up kind of a robust form asking you to pick how many new layers you want to add, and then if you want to add a prefix to the layers that you're adding, and then where they're going to go. So if you say they're going to go below conductor top or above conductor top. And notice if you say that they're going above conductor top, it doesn't let you pick a conductor or a plane layer because you can't really put those above the top conductor layer in the database. but you can say that you're going to have a certain type of dielectric, or you can have your defined mask layers. So the tool ships with a large variety collection of different types of masks, or you can define your own, which I'll show you later on in this video. So the process is to basically pick which type of mask layer you want to add. Let's say you want to add some sort of gold hardtop. You pick its function, and then you pick its material that you want to have for that particular type of layer. I'll pick this, or I'll say it's diamond, for example. And then you hit add. And then now you have a new layer above the top layer. Same thing if you want to add some conductor layers below the top. That's where you could come back in and say, okay, I'm adding a conductor layer and it's copper. Typically, if I'm adding conductor layers, I find it's easier just to use the add layer pair below, and then you're just automatically going to get a conductor layer and a dielectric. So now notice you have layer 1, inner 2. And then you can double click on any of these things and rename them or whatever you want to call them. So that's how you can add the materials of all the different stack ups. And then if you want to add a new region, you can hit this plus sign here. And then now you're creating another specific stack up. And I'll just, for example, call this Flex 2. And then you can say you want to copy the stack up from the primary layer, or you can pick any other stack up that you've already created and defined. So if I say I'm going to copy the stack up from primary, hit OK. Now we have this new column header, and notice it copied everything over. And now you can subsequently go through and you can say, well, this particular flex zone doesn't have that layer, that layer, that layer. It only has this one layer, it's dielectric above and below it, and then nothing else. And so now if you were to look at this kind of cross-section chart here, you see you have that other cross-section that goes like that. And then you could also, uncheck those things from other layers if you don't want those to exist. So between building up all stack ups, and then you can individually look at what exists in my primary stack up, what exists in this flex stack up, this stack up, this stack up, this stack up. You can then define all of your different stack ups that you need to use throughout all the different areas on your board. Now, of course, with almost every function in the tool, these things can be imported and exported out so you can reuse them over and over again. So if you build up a nice cross-section stack up that you don't want to manually rebuild all this stuff, I'd recommend exporting it out into a cross-section technology file, save that off, so then the next time you need to do something, you can import it in. You can also import and export this stuff from IPC 2581, which is something that a lot of fabricators can share with you as well. And there's all sorts of other things that you can do in this cross-section chart, but generally speaking, that's how you create different stack ups and assign them to different parts of the board. Okay, so when you're all done, you go ahead and apply that, and then that's going to give you your cross-section. All right, the next thing we're going to do is apply those different stack ups to different areas of the boards, or what we call a flex zone. I'm going to want to create a certain zone in this area of the board here, which is clearly going to be a part where it's going to bend. One of the things that you can work with inside of Presto to help in doing rigid flex design is just generally being able to adjust the visibility. So let's say you have a design, something like this, where you just have a whole bunch of stuff turned on, right? You're going to want to kind of clean up your display a little bit. So sometimes what I find is easy is just to turn everything off. And then you can, for example, turn on your design outline, maybe turn on your component pin so you can see where those things are at. And then also in this visibility panel, there's different categories for different types of functions, and there's one specific category for rigid flex. So anything that is rigid flex related is going to be inside of this rigid flex area. So if you are working with rigid flex and you really specifically want to see something like that, it's going to be in this rigid flex area. So you can get your display set up so you have a nice set of visually what you want to look at and what you want to work with. And then even if you like this display, just another quick tip here, you can hit this little plus sign here and you can type in something like flex, right? And then save that. And then you'll be able to recall that view at any time. So if you get a view to look like something like that, you can use the view pull down there, the view pull up here, and then get back to that view at any given time. All right, so that was a little bit of a sidetrack, but we're going to create a flex zone right here. So I'm going to kind of zoom in a little bit, maybe unpin some of these things so I have more working area in the design. And then we have a specific command to set up a flex zone and a flex bend. So the first thing we're gonna do is create a zone. The zone can be drawn in using a polygon or a rectangle or a circle. Note that, even though this board outline in this flex zone has these little intricate curves that came in from the design outline, you don't have to trace those exactly because the tool's smart enough and it's gonna clip the zone to the design outline. So for example, you can just go into rectangle and just click and then hold your left mouse button and zoom in around here. And if you were to kind of stop right about where that line's at and click, it created the zone and it automatically clipped it to the board outline. So you don't have to explicitly draw this intricate shape is the point I'm trying to make. You just have to cover it with kind of a blanket, so to say, and then you'll end up with the zone. And then this is where you set the stack up that you want to use, right? Remember before you just made those stack ups. So here you're gonna say this is zone 1 and it uses this particular stack up. And then if you want, you can even lock that shape to prevent yourself from accidentally editing it later on. So, if you have a more complicated thing like that, that's when you might want to go in and use the polygon mode to kind of draw in and kind of pencil in around something like this. And again, you don't have to be really precise. As long as you kind of cover that whole area, it's going to trim it to the board outline. So that gives you the different zones in the design. And if you ever want to see all the zones, you can click on the design outline, and at any given time, it's going to tell you how many zones exist in the design and how many bends. And if you click on that blue hyperlink there, that then allows you to navigate through all the different zones in the design. And as you navigate through them, you can see in the property panel which stack up is being assigned to which particular zone. Okay, the next bit we're going to talk about is bends. These are the particular parts of the design where the flex is actually going to bend. For example, if you look into 3D Canvas here, we zoom in, you can tell that, if you zoom in real closely, you can tell that there's a multi-layer stack up there and that that particular flex only exists in a couple of the internal layers. And then if we were to, let's pin this back in place, go into the bends, these are bends that are already existing in the design. So these things specify where the flex folds and how far it folds at what particular radius. And there can even be an order associated with them. So if you have something really complicated where this thing has to fold up first, then this, then second, you can have a 1, 2, 3, 4, 5 type of order to fold all the bends. So we're going to put another bend right in this area right here. Let's go back to 2D. So back onto the setup menu, flex, create bends. And here it's going to kind of give you just kind of a quick walkthrough. Effectively what you're doing is you're just drawing a line, right? This line here represents where this bends, this line represents where this bends. So effectively you're just going to click and draw some linear line somewhere where you want this to bend. So we're going to click here and then we'll click there, and that has created a bend. Once that bend line has been drawn, you can name it. You can then modify its XY start, and then you can specify whether the start's on the top or the bottom, which kind of dictates, is it, folding which way, from the top over or from the bottom over. And then you can fill in these diameters and radiuses of the bend. So you can say this has an inner radius of 10, and it folds over 180 degrees. Okay, and this is that order that I talked about. So if this happened first, second, or third. And then notice you can also, it's automatically going to create this area around it, which you can have be a via keep out and a package keep out. Typically, you're not going to want to put vias on there or components on there, because when it bends and folds, those things are going to pop off and break. So you're kind of intelligently building something that can actually be fabricated as well. And if you want to oversize these things, you can. And then once you're done, you could lock that bends line so you don't actually escape it, and then you can hit escape, and now you have a bend line in the database. And again, if you were to select the design outline, you can once again navigate to see where all the bends are at as well. Let me pin this, and you can then navigate all the bends, and you can see all the bend line attributes, and if you need to modify them, you can unlock them and modify them. By default, once you create a bend line, we automatically apply the lock, because most people typically don't want to accidentally or advertently modify them when they're moving other things around in the design. So once that bend exists, then if you were to go back into 3D, now you have that other bend line in place, and you can see that applies that bend, which folds over 180 degrees at that particular point. Next, I'm going to talk briefly about DRCs specific to Flex. When it comes to Flex, there's a lot of coverlays and materials and masks that get applied to the design process, and in which case there's specific DRCs that you need to check for. Often we refer to these as interlayer DRCs, because it's something on one layer with respect to something on another layer. A perfect example of this is where you may have some sort of coverlay that needs to completely have windows cut in it for different pads. And if the pad moves, you want to make sure that that coverlay has a certain opening of it above it as well, with a certain expansion. Other examples may be, when you have a bend line, what I just discussed, you don't want to have any vias or pad stacks or pins inside those bend lines. All of that can be set up inside of the constraint manager. There's a specific section for interlayer DRCs, and it can look a little complicated at first, but all you really effectively need to understand is it's a matrix. Every layer that you have, conductive or non-conductive, in the cross section is going to be a matrix of a from to every other layer. So if you want to set up a specific rule, for example, of film mask top to this tin plating top layer, you can create a rule between those two layers. So you check the box to say that you want to create that rule, and now you have defined one particular rule. So you're checking something between this layer and this layer, and then you can specify whether you need to have a gap or an overlap, or layer 1 needs to be inside layer 2, or layer 2 needs to be inside layer 1, and then what that particular spacing value is. And then you can enable that DRC and even put a specific layer label on it. So you can call it film to tin, and then add a description. I'm sorry, the label is an individual letter that gets appeared on the DRC marker, and the description is where you can freeform type, right? This is a bogus example, of course. This applies something nobody would ever check, but I'm just showing you the mechanics of how you can build up any layer-based checks you want to have in the tool for Flex and Rigid Flex. There's a couple of ways you can draw in those different shapes for the Flex-based DRCs. Firstly, you can use the Add Shape command to draw a rectangle, circle, or polygon, and then you can specify the shape used as Rigid Flex, and then you'll have access to the Rigid Flex layers that you put in the cross section. So for example, if you just want to draw a rectangle representing a stiffener, you can click and draw that in, and you have a rectangle for the rigid stiffener. Once you have drawn any particular shape, anytime you double click on the shape, you then always have these handles that you can kind of resize the shape after you've drawn it, very similar to what you'd get in PowerPoint. And then even notice you get the little heads-up display telling you what you want to do there. Another option you can do is, if the shape that you want to put in is based on some existing shape that's already existing in the database, you can use the paste special command. So for example, let's say you have this zone boundary. You can select that zone boundary and do a copy, and then choose paste special. Now you have an exact copy of that boundary on your cursor, and now you can change it to something else. So you could say, I want to change what I just copied to a stiffener top on that rigid flex layer, and then you could paste that down, and now you've copied that. So you can effectively do that paste special with any shape in the design. You could copy the whole design outline and copy it and change it to something else using paste special.